Dear students, under the lecture series on complex analysis, we are solving problems under Taylor series expansion. Here we have a problem which says that expand f of z equal to sine z in a Taylor series about z equal to pi by 4 and also determine the region of convergence. This is one of the significant problem which has appeared in one of the previous year question paper. In our previous four problems, we have already seen how to expand by using Taylor series. So we shall first write the expansion of Taylor series for that. So the Taylor series about a point z naught is given by f of z equal to f of z naught plus f dash of z naught by 1 factorial multiplied with z minus z naught plus f double dash of z naught by 2 factorial multiplied with z minus z naught the whole cube plus f triple dash of z naught by 3 factorial multiplied with z minus z naught the whole power. I mean, here I have written cube by mistake, so it is square and here cube. Since when we have double dash, it will be square here, triple dash, cube here, and this series keeps on going, and we have to substitute f of z over here. So what is f of z? It is equal to sine z. So let us take and substitute that. So sine z is equal to, and this is about the point pi by 4. So what is z naught here? Z naught is equal to pi by 4. So we shall substitute that. So f of pi by 4 plus f dash of pi by 4 by 1 factorial multiplied with z minus pi by 4 plus f double dash of pi by 4 by 2 factorial multiplied with z minus pi by 4. And this series keeps on going. Let us write the third term also. So plus f triple dash of pi by 4. That is the fourth term actually this is. By 3 factorial multiplied with z minus pi by 4 the whole cube. So this is square as per the expansion. Kindly make note of the powers. Do not forget it. So here square and here it is power 3 plus etc. Now we shall find each of this, for which first we should write f of z which is equal to sine z. Now from this, what is f dash of z? The differentiation of sine z is cos z. And then f double dash of z which is equal to differentiation of cos z which is minus sine z. And then we have f triple dash of z which is equal to differentiation of sine z is cos z, and since we have this minus, we will be having cos z. Now, from this, we see that f of pi by 4 will be equal to, so from this, what do we see? F of pi by 4 is sine pi by 4. And what is sine pi by 4? It is 1 by square root of 2. So 1 by square root of 2. This is by the trigonometric angle formula, that is sine pi by 4 is 1 by square root of 2. Okay, so 1 by square root of 2 actually. So this is sine pi by 4. Now from this we can write f dash of z, that is pi by 4, is equal to cos pi by 4. So what is cos pi by 4? It is also equal to 1 by square root of 2. It is same for both sine as well as cos. And what about this? F double dash of pi by 4. It is equal to minus sine pi by 4. And we know that sine pi by 4 is 1 by square root of 2, and so this will be minus 1 by square root of 2. And finally we have f triple dash of pi by 4 which is equal to minus cos pi by 4. And cos pi by 4 is 1 by root 2, and so this will be minus 1 by square root of 2. Now we shall substitute all this 4 here in this expansion. So therefore the expansion turns out to be sine z is equal to, what is f of pi by 4? It is 1 by square root of 2. So 1 by square root of 2 plus f dash of pi by 4 is 1 by square root of 2 divided by 1 factorial multiplied with z minus pi by 4. And then we have f double dash of pi by 4 which is minus 1 by root 2. And so we can write it as minus 1 by square root of 2 by 2 factorial multiplied with z minus pi by 4 the whole square. The next term is also negative, and so minus 1 by square root of 2 by 3 factorial multiplied with z minus pi by 4 the whole cube plus etc. It keeps on going. And when we put together, what do we get? We see that 1 by square root of 2 is common in all the terms, so we can take it out, and so therefore sine z will be equal to 1 by square root of 2 we can take out, and so within the bracket we will have 1 plus z minus pi by 4 by 1 factorial, and then here a minus, so minus z minus pi by 4 the whole square by 2 factorial, and then again a minus z minus pi by 4 the whole cube by 3 factorial plus etc. The term keeps on going. So this is the Taylor series expansion for f of z is equal to sine z. And how about the region of convergence? We know that trigonometric functions are analytic everywhere, and therefore the entire complex plane becomes the region of convergence, and therefore the expansion is valid in the entire complex plane. So I have written that therefore the expansion is valid in the entire complex plane. So you have to conclude the problem like this because they have asked us to determine the region of convergence. So I hope you would have understood these kind of problems. In our future lectures, we will solve more important problems under this topic. Thank you.